All right, so just to kind of look at this, I filled mine in. But the goal of this worksheet is to really just help you that when you're looking at a problem, to kind of give you an idea as to like where to go, what to look at, what to think about. So the first question up there, always try and take out a GCF. So that's the first thing. Like when you're looking at any problem, the first question you need to ask yourself, is there a GCF? The second thing, you're going to choose and do a method based off the number of terms. So if there are 2 terms, then you would obviously go to that part of the flow chart. If there's 3 terms, you'd go to the middle. If there's 4 terms, there's only one option with 4 terms. It's factor by grouping. So I think the 2 terms part is the part that it seems like people are having the most difficulty with. And that's deciding whether it's a difference of 2 squares or it's a difference of 2 cubes or sum of 2 cubes. The grouping, everybody seems fine with grouping. Like there are 4 terms, you got to group. 3 terms is AC grouping, so it's doing the AC part that we've done a lot of, but then just continuing to factor it using grouping. So the goal of the sheet, because tonight's homework, the factoring problems, like you're going to use 3 of these methods in one problem. So the goal of the sheet is like if you look at your problem, how can I start to approach the problem? And then once you do like the first step, then looking at your answers, okay, this answer, this piece of the factor matches 2 terms, so I'd want to factor it further. Or this piece of it matches 3 terms, so I want to factor it a little further. But it should hopefully be helpful when you're looking at a problem and kind of deciding what to do with the problem, how to start factoring the problem. So today we are going to answer some questions from the homework. We have one word problem to look at that involves multiplying and factoring. So foiling and factoring, essentially section 5.3 and 5.4 kind of combined together in one problem. And then you'll have some time to practice to start working on the weekend homework, which is a factoring worksheet. Monday we're reviewing, and Tuesday you have a quiz on exponents, adding, subtracting, multiplying, and factoring. So there are 3 concepts that we talked about, but like the factoring concept, I mean there's a whole bunch of different ways to factor when you're talking about factoring. Monday also, if you want to do the retake, you have to have that review worksheet to me on Monday. And then the retake is up to you when you want to take it. It just has to be done by December 22nd before we leave for our little winter break. Any questions? So my suggestion would be to have this chart out as you're working through the factoring, just to kind of reference it. If you're not sure about how to approach a problem, you can at least try and match it up with what's on here and then say, all right, it has 3 terms, so I want to use AC grouping. Sarah?
Is it like by yourself, or can you do like a small group?
For, oh, you'll have time to work with the partners. Like this has x to the 4th here. You still have to do, yeah. Even if it was x to the 6th, x to the 8th, any even power there, you would use AC grouping. So as long as it's 3 terms, you're going to do the AC grouping. All right, so if you could take out your homework, hopefully you realize the answers were on the back. What questions would you like to go over on the homework? Emma. 28. Okay, so for number 28, if we're following the little flow chart, the first step says always try to take out a greatest common factor. So in number 28, is there a greatest common factor? Yes. So they all have an R in common. common, so that should be the first step. Take out an r. Do they all have something else in common, Sarah?
3.
A 3. So looking at the GCF, we could take out a 3 and an r. And Sarah, when we do that, what do you have left then?
R to the 4th plus 5r squared minus 6
Equals 0. So now looking at the inside, I have 3 terms. So if you go down in the 3 terms, we have that AC grouping process. So we're looking at the number -6. No? And she said a -1 and a +6. Because we have a -6 on the top, and we're trying to get a +5 in the middle. So we have r to the 4th, which is okay. We still factor that as a trinomial. And then -1r squared, +6r squared. That's the only difference. Whatever the middle term is, has to match when you're writing it out. And then a -6. So now this is the grouping part where we put a line down the middle. Once you have 4 terms, it's grouping with 4 terms. So take out the r squared. That leaves us with r squared minus 1. Take out a +6. That also leaves us with r squared minus 1. Okay, so far we took out a GCF, we used AC grouping. Is there anything else to do to factor it completely? Emma?
The r squared minus 1 is
And it breaks up as?
r minus 1 and r plus 1.
Right. The other one cannot be factored because 6 isn't a perfect square. So cannot be broken down, and there's a plus sign there. That's as far as it goes. So this is considered completely factored. So if the directions said factor it completely, I now have it factored completely. Pulled out a GCF, used AC grouping, and then did the difference of 2 squares for that second term. The directions ask you to solve for all real solutions. So find the real number solutions of the equation. And that means that you need to take everything that's left in the parentheses and solve for each piece of it. So if we solve for 3r, if I'm solving, it means each piece should be equal to 0. So Mitchell, that means r is just going to equal
0.
0. So r is equal to 0 here. That's one solution because there's a variable there. Anytime there's a variable, that's going to give you an answer. If you solve the next one, setting it equal to 0, Mitchell, what do you do here to set it equal to 0 and solve it? How do you get r squared by itself?
You gotta make it. Make the -6.
Yeah, make -6 and then
And then you square root it.
square root it. What happens when you take the square root of -6?
You need the I.
You need the I. So is this considered a real solution if there's an I?
Nope.
No. That's why that answer isn't on the back. Because this is an imaginary, we have the square root of -6. So if you can't factor it because there's a plus sign there, that gives you an imaginary answer. So that really isn't part of the real solutions. And then the other real solutions, well here r minus 1 gives me an r equaling +1, and r plus 1 tells me that r is going to equal -1. So these are the real solutions. The imaginary solution would be plus or minus I in the square root of 6. But really that's not a real number, so that's not listed on the answer sheet because it really isn't a real solution. Good question. Any questions on number 8? 20. Sarah?
I was going to say
Yeah, sure.
another question.
Yep.
27.
27? So 27 says y to the 4th minus 14y squared plus 45. So Sarah, how do you think you'd start solving it?
You'd make it the middle term into 2.
Uh-huh.
So it'd be -5 and -9.
Right, yep, so she said -1 and -9. So we would have y to the 4th, y squared, 9y squared plus 45.
Should that be -5y?
Oh,
-5 and
yep, thanks. Okay, thank you. And then take out a y squared. So that leaves us with y squared minus 5. Take out a -9. That leaves us with y squared minus 5. So then we would have y squared minus 9 and y squared minus 5. So Sarah, can it factor any further?
Yeah, you can take y minus 3 and y plus 3.
Right, so that first one can be broken up. It's 2 squares, the difference of 2 squares, so y plus 3, y minus 3, and then we still have y squared minus 5. So if we solve it just like we solved the previous problem, the first two would give me a -3 and a +3. And then the third one, if we set it equal to 0, take the 5 to the other side and take the square root. What are your two answers with that? Right, plus or minus, and then the square root of 5. So the plus or minus sign is there because you're taking the square root. You are applying that in the answer. So anytime you take a square root, you get a plus or minus. No one?
I have two questions. So the number of answers you get is always one more or one less
It's going to
than
be
grade
equal to it.
grade okay.
So equal to it or less than it if there's imaginary answers.
Okay.
So it'll either be equal or less, never more. That's the most that you can have. And then your second question? 17. Shaylin,
Can we do the 20
say it again.
either 20 or 22?
Okay. And Sarah.
I have a question for like 28. So, like saying the power one,
Yeah.
like how many answers you'll have. What if like you take out like a greatest common factor? Would it still be like,
That's still part of your answer.
or would it like to get the number of answers? Would it be at the beginning of the problem?
Yes. So at the original problem tells you how many answers you should have. Okay, so Noelle said 17. And then 20 or 23 you said, right?
23.
So 17 says x to the 6th minus 4. So if there are two terms, we have the option of difference of 2 squares or difference of 2 cubes, since it's a minus sign. So those are our two options.
Hello.
Hi.
I heard that there's a piece of paper that we have for homework. Okay. Thank you. We're just doing nothing in a course today, so we can watch for a second.
Sure. Why not? So does this match with the difference of 2 cubes? No, because 4 isn't a perfect cube. So the only other option we have is a difference of 2 squares. So if it's a difference of 2 squares, then that means we need to take the square root of both pieces. What is the square root of x to the 6th? Sarah?
X to the 3rd.
X to the 3rd, because x to the 3rd times x to the 3rd makes x to the 6th. So the square root of 4 is
2.
2. So this would be x cubed plus 2 and x cubed minus 2. And then that's it. Like it can't be factored any further because 2 isn't a perfect cube. So using that difference of 2 squares pattern is how you would factor it, and then you're done. No other factoring. And then you said 20. So number 20, Shaylin, how did you think you would start it, or how did you start it?
So I was really easy.
Yeah. That's right.
Like my answer didn't match up. Like,
Okay. So you did AC grouping. What numbers did you use?
1 and 6.
1 and 6. So you have a to the 6 plus,
1 and 3
good.
plus 6 a to the 3rd plus 6.
And then lying down the middle, what do they have in common?
First one's a to the 3rd.
So then that's still a to the 3rd plus 1. The second one is
6.
a 6, and that's a to the 3rd plus 1. So we have a cubed plus 6 and a cubed plus 1. So looking at both of those answers and then going to the little sheet, there are 2 terms up there. Do either of those answers match one of the patterns in the 2 terms column? Is that?
Is it the sum of two cubes?
It is the sum of 2 cubes. Why is it the sum of 2 cubes? What's the cube root of 1? 1. So it doesn't look like it should factor any further, but the cube root of 1 is 1. So you can use that sum of 2 cubes. I like calling it the SOAP formula. So I would have A, same sign, B. The cube root of 1 is 1. And then A squared, opposite sign. A times B would be A times 1, which is just A. Always a plus sign back there. And then B squared is 1.
I was just so confused with like the extra set of parentheses and I didn't know which one.
And you're like, where the heck did that extra set of parentheses come from? Alright, I can't answer any more questions because I do need to get moving on. If there are others, you can feel free to circle that and ask it at the end of class. But I want to make sure that you guys have time to do some in-class work. So if there's another question that you have, circle it so that you know you need to ask about it. In your notes packet, there's a little word problem. This is on page 15, same page we were working on yesterday. So you are in charge of designing a marble basin that'll hold a fountain for a city park. So if you think of like a flower pot that maybe you have on your porch, this is just bigger because we're holding a fountain instead of a flower pot. The basin's sides and bottom are going to be 1 foot thick. If we're filling it with water, water is very dense, it's heavy. So we need something to hold that water in, so we've got these nice thick sides. So a foot is like, if you look at the tiles, that's a foot. Each one of those tiles is a foot. So that's how thick the sides of the basin are. So in the little diagram, each side is 1 foot in thickness. It also says that the outer length, the length is the part in the front. So when you talk about length, that's this part right here. The width is almost like the depth. So the depth or the width. It says the length should be twice its outer width and height. So instead of it just being x, if x is the width and the height, the length is twice that. That's how we get 2x. So twice means doubling that value. The other information, it says, what should the outer dimensions of the basin be if it's to hold 36 cubic feet of water? So if we're dealing with cubic feet of water, what kind of formula would we be thinking about? So what formula goes with cubic feet? 10? Yeah, so he said length times width times height, and that's the formula for volume. So that's the volume formula. So if you have water that you're pouring inside of something, we're finding the volume of that. And the other thing, just that I'm going to kind of note on here, it says that the bottom also is a foot in thickness. So this bottom here, the water doesn't go to the ground. Like, it has to have a bottom. Otherwise, the water, even if it was on a flat surface, is still going to seep out and you'll lose your water. So the base of this is also a foot as well. So the water really goes a foot above the ground because it has a base. So how do you think we would try and use the volume formula that Ben gave us and the information from the diagram, from the description, to try and come up with some formulas? So think like, how would the length, what would the length be? Right here's my water. How much space does the water have in length to take up? So what would the distance be of that inside of the basin? Ben? You're so close. So the length is 2x, Ben.
Oh, okay.
So it would be 2x minus 2. So this length, the whole thing is 2x from outside to outside, but we're on the inside and we have to take away the foot on either side. That's why it's minus 2. So the inside space is 2x minus the 2 feet that I have to take away from it. So Ben, therefore, then the width, which is this part right here,
That would be
that's the x minus 2. So my width was x, but when I take away the 2 feet on either side, the foot on either side really, but that 2 foot of space, we have the x minus 2. And then how about the height then?
X minus
Why is it just 1?
because there's no ledge.
Yeah, there's no ledge on the top. If there was, then we wouldn't have water flowing out of it. So our formula, 2x minus 2 for the length, x minus 2 for the width, and just x minus 1 for the height. So the minus 1 is that base, that foot base that we have. And then that is equal to 36. As we have 36 cubic feet of water that we want to go into this basin so we can have this pretty little fountain. So now that it's set up, how would you solve it? What do you need to do to solve it? Huh? Say it again?
Get it on one side so it's full.
Yeah, you need to FOIL it. What should it be equal to? What number should it be equal to? If you're solving any problem.
Oh, 0.
A 0, yeah. So any problem that you're solving, be using factoring. If you're going to factor, everything has to be equal to 0 with the factoring. So we need to FOIL this, get it equal to 0, and then factor it. So you're kind of doing multiple things here. When you're FOILing, totally up to you how you want to FOIL. I would probably FOIL x minus 2 and x minus 1 together first, because they're both just x minus something, and multiplying them together is pretty easy. I also like to have the trinomial in the back and multiply the binomial to it. Again, that's just me. So this is 2x minus 2 here. So see if you can get this to FOIL and then factor. So when you're multiplying, just watch those signs, watch your powers as you're multiplying through. But you're taking the 2x through and then the negative 2 through if you multiply the back 2 together. Mitchell, do you have an equation that we're going to try and factor?
Sure. 2x to the third minus 8x second plus 10x minus 4.
And instead of minus 4, if we also subtract that 36 in the same step, it would be
Minus 40.
minus 40. So factoring it, first question, is there GCF? Yes. What's the GCF, Mitchell?
2.
2. And then what process would you use to factor it, Mitchell?
You put the line in between.
Yeah, so that's the grouping. Put the line down the middle, pull out what the first pair have in common, pull out what the last pair have in
Wouldn't it be minus 20?
Oh, yeah, sorry, thanks. And take out the 2 there. Thank you. So pull out an x squared. Pull out a 5. So when you're finding the solutions, the 2 in front doesn't have a variable, so that's not part of the answer. It doesn't affect anything inside the parentheses. You took it out, it's done. Go on with that. The x squared plus 5, if we set that equal to 0, we take the 5 to the other side, and if we take the square root of it, you get, Shaylin? Right. Can an imaginary number be part of your solution? No. Just like a negative number can't be part of the solution. You can't have a negative length, you can't have an imaginary length. So that one isn't part of the answer. So Shaylin, then x is just equal to 4. All that work for x equals 4.
So you don't have to do any, I know that you just talked about the 2, but you don't have to put it back in.
You don't put it back in, it doesn't affect it because you end up dividing it out anyway.
From the very first equation, where do we get 2x minus 2, x minus 2, and x minus 1?
Okay, so the 2x minus 2. So the whole thing is 2x.
Okay.
The whole length. But the inside space, because there's those borders that is a foot thick, so my inside space has to take into account that the entire thing is 2x, but it's going to shrink by a foot on either side. So that's how you get the minus 2, because 1 foot and another foot would be
Okay, I
minus
forgot
2
to add
feet.
2. Okay. I was thinking it should be 1, but I forgot both.
But because both sides, yeah.
Okay.
The base is only 1 because the height, there's not like a cap on the top of it.
Yeah.
Other questions? So what should the outer dimensions be? If my x is 4, the outer dimensions of this, it's going to be 8 feet in length, 4 feet in height, and 4 feet in width. So it would be 8 by 4 by 4, which really isn't that big of a fountain.
Okay, so I put the first 2 when I was doing it, and I ended up like doing it wrong.
Do you have 2x squared minus 6x plus 4?
No, I have minus 4x. 2x.
So here's this guy here. So here's 4x, and then that's a negative 4x and a negative 2 make it negative 6x.
Okay.
Other questions? So when you get this worksheet, I'd like you to look at number 17.
No, every time I see it go up, I check myself immediately. Yeah, I'm not even kidding. I could almost take like all of it, and we get a photographer to take a I just saw it.
Okay, really quickly. If you look at number 17, it has a power of x to the 9th. That means you're going to use a lot of factoring in this to get it to completely break down. There are 4 terms, so the first type of factoring would be grouping. So I'm going to slice down the middle, take out an x to the 6th, because that's what the first 2 values have in common. That leaves us with 27x cubed minus 1. The second 2 just have a negative in common, so 27x cubed. Am I missing something? Plus here. Okay. There we go.
No.
Yeah.
Oh, with the first one. I want both of them. Okay, I'm down with no.
Wait,
Yeah, because when you take out a negative 1. So grouping x to the 6th minus 1, and then 27x cubed plus 1.
We got a cube on too.
I think it was Noel who asked the question from the homework.
Yeah.
Yes. So this is now like 17. This first part here is very close to number 17. It's the difference of two squares. This one is a cube, so this is the SOAP formula. This one is the difference of two squares, where you're going to take the square root of both pieces. And then after you take the square root of both pieces, Noel, do you know how it factors?
X cubed plus 1 x cubed minus 1.
Both of these are now cubes. And you're also going to use the SOAP formula for both of those. Both. So you're using the SOAP formula for all three of them. Your answer will be huge.
This sucks.
Can you use the SOAP formula for the x to the 6 minus 1 first?
You could fact. No.
No.
She's like, hey, I got it.
Because I had it down.
So like we
So
should
I
have.
got it down to this.
Your turnaround for you saying.
So how can we like
That's it.
x plus 1 so you back to this?
Thank you.
Are we already our
Yeah.
Okay. I wish I really didn't have this. No.